Imagine finishing a CAD model in half the time, generating engineering reports with one click, running CFD simulations faster, automatically creating 2D manufacturing drawings, and even asking an AI to explain why your design failed. Sounds like science fiction? It isn't. Most mechanical engineers still think AI is just ChatGPT. But that's like saying a workshop only contains a hammer. Today, I'll show you every category of AI tools that mechanical engineers should know, from design and simulation to manufacturing and documentation, and how they can save you hundreds of hours every year. Let's begin. Think about your complete engineering workflow. First, you design the product. Then, you analyze it. After that, you create manufacturing drawings. Finally, you prepare documentation and presentations. AI can assist in every single one of these stages. The goal isn't to replace engineers. The goal is to eliminate repetitive work so engineers spend more time solving real engineering problems. Mechanical engineers spend nearly half of their design time not actually designing, but searching for dimensions, calculating formulas, modifying old models, and repeating the same features. This is where AI becomes a real productivity tool. Let's say you're asked to design a gearbox housing. Instead of opening your CAD software immediately, start with ChatGPT or Claude. You can ask, design a gearbox housing for a 5 kilowatts electric motor. Suggest suitable materials, wall thickness, rib placement, bolt spacing, and key design considerations. Within seconds, you'll have a structured engineering checklist. It's not the final design, but it's an excellent starting point. Next, move to your CAD software. If you're using Autodesk Fusion 360, try its generative design workspace. You simply define the loads, supports, materials, manufacturing method, and the region where material is allowed. Instead of drawing one concept manually, the software automatically generates dozens of optimized designs. Some are lighter, some are stronger, some use less material. It's like having an AI design team exploring possibilities while you focus on choosing the best solution. Now suppose you've already created the first model and want to improve it. Upload a screenshot or export of your model to ChatGPT or Claude. Ask, review this gearbox housing. Where could stress concentrations occur? Should ribs be added? Can material be removed without significantly affecting stiffness? The AI won't replace an FEA analysis, but it often points out engineering improvements that you may have overlooked. If your work involves repetitive CAD operations, use GitHub Copilot to write automation scripts or macros for software like SolidWorks or Fusion 360. Instead of spending hours renaming files, creating standard features, or automating repetitive tasks, Copilot can generate much of the code for you. Finally, when you're stuck with a CAD command or assembly issue, don't spend 30 minutes searching forums. Take a screenshot, upload it to ChatGPT or Claude. Ask exactly what's wrong. More often than not, you'll get an explanation in under a minute. The result isn't that AI designs your product. The result is that you spend less time on repetitive work and more time making engineering decisions that actually matter. Now let's move to one of the most time-consuming parts of mechanical engineering, CFD and FEA simulations. Imagine you're designing a centrifugal pump impeller. Normally, you'd spend hours deciding the turbulence model, setting boundary conditions, generating meshes, and checking if your simulation has even converged. Instead, start with ChatGPT or Claude. You can ask, I'm running a water flow simulation for a centrifugal pump in ANSYS Fluent. Which turbulence model should I choose? What inlet and outlet boundary conditions are appropriate? And what should I monitor for convergence? Instead of searching through forums for an hour, you'll get a structured explanation in seconds. Next, if you're using ANSYS Fluent, ANSYS Mechanical, SimScale, or Autodesk CFD, AI can help interpret your results. Take a screenshot of your pressure contours, velocity vectors, or stress plots, and upload it to ChatGPT. Ask, why is there a high-pressure region here? Or what could be causing this stress concentration? While AI won't replace engineering validation, it can quickly identify possible causes and suggest areas to investigate. For engineers running multiple design iterations, tools like ANSYS OptiSlang use AI-driven optimization to automatically vary design parameters and search for better solutions, saving hours of manual trial and error. And if you use MATLAB for post-processing or optimization, the built-in MATLAB AI assistant can generate scripts to analyze simulation data, plot graphs, calculate pressure drops, or automate repetitive calculations. The goal isn't to let AI make engineering decisions for you. It's to spend less time setting up simulations and more time understanding the physics behind them. Once your design is complete, it's time to manufacture it. And this is another stage where AI can save a surprising amount of time. Imagine you've designed a CNC machined aluminum bracket. Before sending it to production, ask ChatGPT. This part is made from aluminum 6061 using 3-axis CNC machining. Suggest the manufacturing process, recommended cutting tools, machining sequence, tolerances to watch for, and common mistakes. Within seconds, you'll have a manufacturing checklist that helps you review your design before it reaches the shop floor. Now let's say you're preparing CM operations. If you're using Autodesk Fusion 360 Manufacturing, Mastercam, or Solid CM, AI-powered features can recommend machining strategies, optimize toolpaths, reduce machining time, and help avoid collisions, saving both machine time and tooling costs. Quality inspection is another area where AI is making a big impact. Instead of manually checking every manufactured component, AI-powered vision systems from companies like Keyence, Cognex, and Siemens can detect scratches, missing holes, dimensional defects, and surface imperfections in real time using industrial cameras. And when it's time to create manufacturing documentation, AI tools like ChatGPT or Claude can instantly generate work instructions, inspection checklists, standard operating procedures, and even summarize engineering change requests. The result? Less time writing documents, less time reviewing repetitive manufacturing tasks, and more time improving the production process itself. The future mechanical engineer won't be replaced by AI. They'll be replaced by another engineer who knows how to use AI effectively. Start small. Use AI to automate repetitive work. Learn one tool at a time. Build practical projects. Over time, these tools can become part of your everyday engineering workflow. And if you'd like a complete beginner-friendly guide with AI tools, learning resources, and practical workflows for mechanical engineers, download my ebook, AI for Mechanical Engineers. The link is in the description.